Hello everyone, welcome back to the channel. In today's lecture, we are going to discuss one of the most powerful and widely used concepts in object-oriented programming, known as inheritance. Inheritance is one of the four fundamental pillars of OOP, along with encapsulation, abstraction, and polymorphism. This concept plays a crucial role in designing real-world software systems because it allows programmers to reuse existing code, reduce redundancy, and create a logical relationship between different classes. Whether you are a beginner learning programming or an advanced learner preparing for interviews and competitive exams, understanding inheritance is absolutely essential. Inheritance is an object-oriented programming mechanism in which one class acquires the properties and behaviors of another class. The class whose properties are inherited is known as the parent class, base class, or superclass, while the class that inherits those properties is called the child class, derived class, or subclass. In simple terms, inheritance allows a new class to reuse the features of an existing class without rewriting the code. This concept reflects real-world relationships, where characteristics are passed from parents to children. As software applications grow larger, writing the same code again and again becomes inefficient and error-prone. Without inheritance, developers would have to duplicate common code across multiple classes, making programs difficult to manage and maintain. Inheritance solves this problem by allowing common features to be defined once in a parent class and reused in multiple child classes. This approach not only saves development time, but also ensures consistency throughout the application. Any improvement or bug fix made in the parent class automatically applies to all child classes, making inheritance a powerful tool for large-scale software development. To understand inheritance better, let us consider a real-world analogy. Think about the concept of family inheritance. Children inherit physical and behavioral characteristics from their parents, such as eye color, height, or habits. However, each child also has unique traits that make them different from others. Similarly, in object-oriented programming, a child class inherits common properties from a parent class while also adding its own unique features. This analogy makes inheritance intuitive and easy to understand. Inheritance represents an is-a relationship between classes. For example, a dog is an animal, a car is a vehicle, and a student is a person. This relationship helps programmers model real-world systems accurately. If a class does not satisfy the is-a relationship, inheritance may not be the correct choice. Understanding this concept is important to avoid incorrect class designs that can lead to confusion and maintenance issues. In programming, inheritance allows a child class to automatically access the public and protected members of its parent class. This means the child class can use existing variables and methods without redefining them. At the same time, the child class can introduce new variables and methods or modify existing behavior if required. This combination of reuse and extension makes inheritance one of the most powerful features of object-oriented programming. Consider a simple example of an animal class. This class may contain common properties such as name and age, along with behaviors like eat and sleep. Now imagine a dog class. A dog is also an animal, so it shares common behaviors like eating and sleeping. Instead of rewriting these behaviors, the dog class can inherit them from the animal class. Additionally, the dog class can have its own specific behavior, such as barking. In this way, inheritance allows us to write cleaner and more meaningful code. Single inheritance is the simplest form of inheritance, where a child class inherits from only one parent class. This type of inheritance is easy to understand and widely used. It ensures a clear and straightforward relationship between classes. Many programming languages, such as Java and C#, primarily support single inheritance for classes to avoid complexity and ambiguity. In multilevel inheritance, a class inherits from another class that itself inherits from another class. This creates a chain of inheritance. For example, an animal class can be inherited by a dog class, and the dog class can further be inherited by a puppy class. Each level of inheritance adds more specific features while still retaining the properties of its ancestors. Multilevel inheritance helps represent hierarchical relationships found in real-world systems. Hierarchical inheritance occurs when multiple child classes inherit from a single parent class. For instance, a vehicle class can be inherited by car, bike, and truck classes. All these child classes share common vehicle-related features while also having their own unique characteristics. This type of inheritance is commonly used in applications where different entities share a common base structure. Multiple inheritance refers to a scenario where a class inherits from more than one parent class. While this concept is powerful, it can lead to complexity and ambiguity, especially when parent classes have methods with the same name. Some programming languages support multiple inheritance directly, while others avoid it or provide alternatives such as interfaces. Understanding multiple inheritance conceptually helps programmers make better design decisions. One important feature of inheritance is method overriding. Method overriding allows a child class to provide its own version of a method that is already defined in the parent class. This is useful when the child class needs to behave differently while still sharing the same method name. For example, different animals may have different ways of making sounds, even though they all share a common sound-related method. Method overriding increases flexibility and plays a key role in achieving polymorphism. Inheritance offers numerous advantages in software development. The most significant advantage is code reusability, which reduces duplication and saves time. Inheritance also improves maintainability, as changes in the parent class automatically propagate to child classes. It enhances readability, as code is organized logically into hierarchical structures. In addition, inheritance supports extensibility, allowing new features to be added with minimal changes to existing code. In large software systems, maintenance is a major challenge. Inheritance simplifies maintenance by centralizing common functionality in a parent class. If a bug is found or an improvement is needed, developers can fix it in one place instead of modifying multiple classes. This reduces the risk of introducing new errors and makes the system more stable over time. Without inheritance, programmers often resort to copying and pasting code across multiple classes. This approach leads to code duplication, which increases file size, reduces readability, and makes maintenance difficult. Inheritance eliminates this problem by allowing shared functionality to exist in a single parent class. This leads to cleaner, more professional, and more reliable software. Although inheritance is powerful, it is not always the best solution. In some cases, composition, where a class contains another class instead of inheriting from it, may be more appropriate. Inheritance creates a strong dependency between classes, while composition offers more flexibility. Good software design involves understanding when to use inheritance and when to prefer composition. Inheritance is widely used in real-world software systems. In banking applications, different account types inherit common features from a base account class. In educational platforms, students, teachers, and administrators inherit from a common user class. In game development, different characters inherit shared attributes such as health, speed, and abilities. Inheritance allows developers to build complex systems efficiently and logically. One common mistake beginners make is using inheritance where it is not logically appropriate. Another mistake is creating very deep inheritance hierarchies, which can make code difficult to understand and debug. To use inheritance effectively, programmers must ensure a clear is a relationship and keep designs simple and meaningful. Inheritance is a fundamental part of object-oriented design. When used correctly, it helps represent real-world relationships accurately and makes software more modular and reusable. However, improper use of inheritance can lead to tight coupling and reduced flexibility. Therefore, understanding inheritance deeply is essential for becoming a skilled software developer. Conclusion to conclude, inheritance is a core concept of object-oriented programming that allows one class to inherit properties and behaviors from another class. It promotes code reuse, reduces duplication, improves maintainability, and helps model real-world relationships effectively. By using inheritance wisely, developers can build scalable, efficient, and well-structured software systems. Mastering inheritance is a crucial step toward mastering object-oriented programming as a whole. Closing, call to action. Thank you for watching this detailed lecture on inheritance in object-oriented programming. If you found this explanation helpful, please like the video, subscribe to the channel, and share it with your friends. In the next lecture, we will explore polymorphism in the same detailed and easy-to-understand manner. Until then, keep learning, keep practicing, and happy coding. 火箭